is kind of sad in a way because, you know, we wind up, really, some people who look at it too closely almost wind up getting a complex over it. You know, they're like, you know, what's going to happen? You know, we're going to wind up with no animal on Earth. You know, and there's something to be said about that in terms of when we start talking a little bit about food chains and whatnot. If there are certain types of plants, for example, that go away tomorrow, inside of a few months, there won't be anything left of here. So, you know, there are some very critical points in our discussion that we'll bring up. And luckily, you know, nature finds a way to keep that from happening. We also talk about systematics, where we try to so you also know of it as taxonomy, where you actually categorize entities by a certain format. You say, okay, X amount of cells have nucleuses. These type of cells don't have a nucleus. And then these cells that do have a nucleus go on to make multicellular organisms. And so what do they look like? And what kind of characteristic can we use to put them into a different category? So we have ways of essentially separating out and sort of, I wouldn't say pigeonholing because that has a negative connotation, but classifying organisms as we're We also, as we study organisms, there's many branches of study, but there's two key ones that keep coming up, and that's anatomy and physiology. Anatomy and physiology are the two biological subjects that serve as like a platform for just about everything biological, up to and including medicine. Now, keep in mind that medicine is not a science as much as it is an art. Okay? But that being said, there's a lot of things that ride on the backs of anatomy and physiology, like biochemistry, pharmacology, physiology, on and on, until you get to the point where you point out in some branch of medicine and or some kind of healthcare support system. Okay? So you have got to start with the basics. You must know your anatomy, and you must know your physiology before you can move forward when you get into higher studies. So let's talk about that just a little bit more. One way to organize a biology is to take a big global picture and then say, okay, we're going to go from an atom, and what's the next step from an atom? Well, an atom is a unit of an element. It's made up of subatomic particles. You've heard those terms, yes? There's something called a proton, there's something called an electron, something called a neutron. Have you heard those terms?
Yeah.
Yeah.
Which says next step on the atom?
So from the atom, I'm at atom right now. We're going to go up to a molecule. This, by the way, is right out of your textbook. So, and you're basically saying that if atoms have a certain interactive capability, a reaction capability, given the environment, if it supports it, heat, temperature, right pressure conditions, whatever. They come together and they exchange relationships, what we call bonds in chemistry, and then you wind up with something called a molecule. So for example, you've all heard about the scientific markers. You've all heard of the scientific term for water. What is the scientific term for water? H2O. Okay? So that's 2 hydrogens and 1 oxygen. And that's it. Okay? But the way they interact give water a partially charge. And so right off the bat it has a property that you didn't think about as hydrogen or oxygen. Now, you know that hydrogen is explosive, yes? You know that oxygen is catches fire. It basically takes a fire, and it's not explosive, but if you bring oxygen